today I want to go over inverse functions. Okay, so quiet now. Okay, a relation is a set of ordered pairs. All right, the inverse relation is the set of ordered pairs obtained by exchanging the coordinates of each ordered pair. So what you're doing is just exchanging x and y in your ordered pair. The domain of the relation becomes the range of its inverse, and the range of the relation becomes the domain of its inverse. Okay, again, you're just switching x and y. So two relations are inverse relations if and only if whenever one relation contains the element a comma b, the other relation contains the element b comma a. Okay, so you can see that switching happening here to get here. Okay, you're flip-flopping your x and y value there. So over on the example, a and b are inverse relations. So a has these three coordinates. Just looking at that 1, 5 coordinate there. If I look to the same coordinate in b, all they did was switch x and y. So that inverse is now 5, comma 1 instead of 1, comma 5. Same thing for 2, 6. It becomes 6, 2. 3, 7 becomes 7, 3. Okay, so that's how you find an inverse of that relation. So first example here, the ordered pairs of the relation are listed here for you. They're the coordinates of the vertices of a right triangle. We want to find the inverse of this relation and describe the graph of that inverse. Okay, so given our original, our new coordinate points, all we're going to do is switch x and y. So since your y value is -3, that becomes your x value. Since -8 is the x value, it becomes the y value. Not so tough, right? Okay, same thing for this one. We'll flip-flop those two numbers. So we have -6, -8. Flip-flopping here, we have -6, -3. Okay, so that would be our inverse. So now what I want to do is graph both of these. So I'm going to take each of these 3 points, graph them, and connect them. Okay, so plotting -a at -3. There's a point right there. So it's at -8, -3. We'll go -8, -6. And then -3, -6. Okay, so that is your original triangle, right? Now I want to plot the points that we came up for the inverse. So -3, -8. -6, -8. And -6, -3. Here's my second triangle. Okay, so those two triangles are inverses of each other. Now, what I want you to notice, I'm not done yet. If I draw this line in right here in the diagonal, right? What line is that?
It looks like a diagonal.
Well, yes. The XY line or the YX line. Okay? What happens to that original triangle over that YX line? What does it look like happens? It flips, which is also considered a reflection. So your inverse functions reflect over the y equals x line. Okay, so whenever you're graphing an inverse, it should look like it's just reflecting over that line. So it's a good way to tell if you actually found the inverse of that function, is to graph it. Make sense? All right. So I have properties of inverses down here. So if f and f inverse are inverses, that's what this means, by the way. F to the negative first means f inverse. Then if I have f of a equals b, if and only if f inverse of b will equal a. Okay, so they want to interchange that x and y value again. So if I have f of x equals x minus 4, then its inverse is x plus 4. Now it doesn't always just change the sign. It's not that simple. Shh. Hey, pay attention. If I look down further, I can evaluate f of 6 using my f of x function. I plug in 6 for x, so I have 6 minus 4 is 2, right? So I started here, my x value was 6. That's your x value, right? It gave me this value of 2. That's my y value, okay? Plug in a number for x, you get the y value. Now if I take f inverse of 2, which was my y value, okay, and I plug it in for x, I have 2 plus 4 is 6. I'll end up with that original x value. Okay, so it's just showing you that you have to switch x and y, basically. So I want to go to the next page. Yeah. So when the inverse of a function is a function, the original function is 1 to 1. Okay? Recall that the vertical line test can be used to determine whether a function or relation is a function. Okay, vertical line test. You're going to draw on a vertical line and make sure it only hits 1 point on your graph. If it hits more than 1 point on your graph, it's not a function. Okay? Similarly, the horizontal line test can be used to determine whether the inverse of a function is also a function. So since you're working with inverse, you're going to, instead of vertical, you're going to draw horizontal line to see if it's a function. Okay, so that flips. So here, if we draw in a horizontal line, this will be a function for its inverse. Okay? So you draw in a horizontal line, it's only going to hit 1 point. Right?
Yeah.
And yes, this right here is only 1 point. It's not going to hit multiple in that little section. It's only going to hit 1 point. That means its inverse is going to be a function. Now, if I look at this one, they have this horizontal line drawn in. That hits multiple times. That means the inverse of this function here will not be a function. Okay? It will not be considered a function. Because once you take the inverse of it, it'll kind of flip it sideways. And then if you draw your vertical line test, it'll hit more than 1 point. Okay? So I do want to go into actually finding an inverse of a function. So we're going to first find the inverse, and then we're going to graph the function and its inverse. So we got some graphing going on here. So letter A, the first thing I want you to do when finding an inverse is change your f of x to a y, which means the same thing. And then just keep that x minus 3 over 5. Shh. Now, like we did with the coordinate points, remember we just flip-flopped x and y, right? To get the inverse. You're going to do the same thing here. So we're just going to change y to x and x to y. Okay? And from here I want to just solve for y. Okay? So get y by itself on one side of the equation. So for this one, I'm going to multiply both sides by 5. That way over here they cancel out, right? So I have 5x is equal to y minus 3. Now I add 3. So I have 5x plus 3 equals y. Okay, and I can rewrite that to make it look like an inverse function. So I'm going to say it is f inverse of x is equal to 5x plus 3. So I'm just changing that y value back to f inverse instead. It's 5th hour. Relax. Okay, so that's how you find your inverse function. Now what I want to do is graph my original and my inverse. So yes, you can just make an XY chart here and plug in points, okay, to figure out where to plot them. So I know which points are easier to figure out. So I'm going to use -7 and 8. Okay, so if I plug in -7 for x, I get -10 over 5, right? So I get -2. If I plug in 8 to my original function here, I get 8 minus 3, which is 5, divided by 5, 1. I can plot my 2 points and then connect them. Okay, so I have -7, -2, and 8, 1. I didn't give you guys rulers, I'm sorry. I have some. Does anybody want a ruler?
No. Don't want you to do it. Don't worry, I'm very straight now. You don't even need a ruler.
All right, so that's your original. Now what I want to do is plot my inverse. Now how did we find the inverse? What did we do? You flipped x and y. So can't I just take the points that I already have here and flip them to find the other points of that inverse? So instead, I'm going to say this is my x value. So I'm going to go left 2 first and then down 7. And then in my inverse, this would be my x value, so 1. And then my y value would be 8. And again, I can connect those. That was a bad one, but it's fine. That one's really hard to see on the board. I can see it. Okay, then if you were to draw in that y equals x line, okay, I'm just going to dash line it right here. You can see that it does reflect over that line. Okay? You kind of see that?
Yeah.
All right, I want you guys not to do that one. Never mind, I'm going to go through this one. Sorry. I was going to have you do it, but I don't want you to mess it up.
Nice.
No, I'm going to go through the last one. I was going to have you do it, but I'm going to go through it. What? No, you're going to forget a piece that's really important. All right, so we're quiet, please. All right, so we're going to do the same steps through part B. Okay? I have my original function. I'm going to change f of x to y. So I have y equals 3x squared. My next step is to interchange x and y. So y becomes x, and x becomes y. And now I want to solve for y. What should I do first? Don't take the square root first. Divide by 3. Okay, so I have x over 3 is equal to y squared. Now I can take the square root of both sides. Now when I do that, right, I end up getting plus or minus the square root of x over 3 equals y. Okay, you need that plus or minus in there. Now I can say f inverse of x is equal to plus or minus the square root of x over 3. You could also say it's 1/3 times x. It's the same thing. So now we want to graph those. So again, finding these points from our original. Okay, I'm going to use -1, 0, 1, and 2. Because why not? So if I plug in -1 for x, I get 3, right? Plug in 0 for x, we get 0. Plug in 1, again I get 3. And plug in 2, I have 2 squared, which is 4. 4 times 3 is
12. See, not too slow.
That was pretty slow.
Like who?
All right, so now I want to plot these points for my original. So I have -1, 3. I have 0, 0. I have 1, 3, and then 12 will go off that graph. Okay? So you should make this parabola shape here. Okay? Kind of see it, right? All right, so then I want to graph my inverse. So again, for your inverse, your x and y values just flip-flop. So if you do want to write those out so you don't get lost, you'd have 3, -1, 0, 0, 3, 1, and then 12, 2. Okay, so you just flip-flop those x and y values, and then you can plot those points. So right 3 down 1, right 3 up 1, and then that goes off. And it does need to look like that parabola there, but sideways. Now, before at the top of this page, when I said you do that horizontal line test, so on one like this was my original. If I did that horizontal line, it would hit 2 points, meaning that inverse is not a function. Okay? So if you did the vertical line test on this one, right, straight down, it wouldn't be a function. Okay? That'll happen when you have this plus or minus with a square root. Okay, questions? Questions on inverses? Not too bad, right?
Ethan.
Right.
Like,
That's a good picture. Eric.
Like, I'll
Good
Ryan,
Oh,
All right, please get started on this. Work through those problems.
Okay, you guys, should I put the picture in there?
Oh, what's a pad?
You know what I'm talking about?
Put it in there, dude.
Here.
Well, we're gonna get
Oh,
them
going
all.
anyway.
Done.
Don't you worry.
Yeah.
I don't know if you can read that.
Right here. Start working on that.
Tyler, you put. You want?
Top that.
I got it.
Down some straight ones.
Put him back here.
Remember when we found one yesterday? Did you pick up Alamo yet? Yes.
Find the inverse of that. Like the first one that we did. What do you do?
Yes, freaking turn them on out.
Yes. So write that down. Go. Come on.
I'm almost done, no
What
yellow.
it means, right?
Wow, Keegan.
Hey, buddy, that's bad.
Oh, yeah.
Yeah, you do.
Oh.
That first one, though. Oh,
She's